Okay, I think we are all set, so let's start with some easy and basic and warm-up question for our speakers. So I start with Daniel. Today you told us about some malicious machines that our fridge may become sometimes Terminator and try to kill us. So my question is, to what extent the Stephen Hawking or Elon Musk might be right about the dangers of artificial intelligence?
Well, to a certain extent, you could say they're right, but not completely. What Stephen Hawking and Elon Musk were even talking about is about artificial general intelligence. So basically Skynet and stuff like that. So I could personally say it's somewhat difficult to create because I don't know if many of you have seen the movie Iron Man, and Tony Stark speaks to his computer, which is named Jarvis. He tells Jarvis, do this, calculate that, and stuff like that. And so I thought, that'll be an interesting tool to have for myself. So I started doing lots of research on that idea, and unfortunately it's not that easy to create. And even if I did create something similar to that, it's going to take quite some time to actually perfect it. So in terms of the Terminator coming after us to kill us, we don't have to worry about that for quite a very long time. However, that does not mean that AI is already somewhat dangerous. Like I have mentioned in my presentation earlier before, the invention of deep fakes, being able to manipulate videos and images, is already dangerous, because imagine propagating false information, someone saying something false, I don't know, world leaders saying that we're going under attack, what kind of chaos it will create. So AI is already dangerous, and this is something that we should be aware of. But in terms of Terminators and stuff like that, we still have some time before that could happen.
Okay, maybe Karol.
I think, Terminator is a good example, but something more new, Westworld. I don't know if you saw this series. So if we talk about AI conquering humans, we need to think about something like in Westworld, actually the hosts, not hosts, hosts from Westworld will do something with us, but they need to change, like you saw in the series. So so we still are far away from AGI. Before that, I expected we will have our AI winter, and even more, in my opinion, it's not only about winter. It's not only about the way how we do it. But
can I interrupt you for a second, because I think that some folks might not know what is AGI exactly, what the shortcut mean.
So let me shortly explain. If you saw my presentation, I explained as well. The AI we can divide into AGI and AI. So AGI is a artificial general intelligence, and ANI is artificial narrow intelligence. The narrow intelligence, the narrow part, is about domain-specific solutions. So machine learning applied for skin cancer, for autonomous cars, and something that is really specific for just doing one task. And AGI is more about a solution that will actually train. Let's imagine you are developing a solution that will recognize a cancer, but at the other end, it will be able to learn something totally different, like driving cars by themselves. So it will be something that will be more generic, more general, and this is something that we think would potentially be a solution that could potentially conquer humans. But again, we need to be at the stage on Westworld, maybe one day. But before that, I think that AI winter will come, and even more machine learning, because it's based on statistics mostly. I think it's good, but I think it's not good enough to implement AGI. I talk with many people on that, and there are some weird ideas like combining all of the methods available to build a super method that will be allow us to build the AGI. But at the end, I don't think it will. Well, it is possible to do it in this way. It's not possible to do it in this way, and we need to wait until there is another way to implement artificial intelligence, not machine learning. I don't know what exactly. No one knows, but we will find it out when it's there.
Okay, Piotr, it's time to confess. Do you agree with your boss?
Yeah, definitely. I have to agree with guys that we are far away from creating the artificial general intelligence. But on the other hand, we have the organizations like the OpenAI, which were created to provide open access to state-of-the-art methods for artificial intelligence. And what happened is they announced the GPT, the model for generating text, and they decided to not release the largest model because they thought that it might be used in a wrong way. And if you look at those fake news or fake stories generated by those models, you can see that maybe they were right. So agree that the danger comes not only from the AGI but also from existing machine learning models.
Okay, go on, Karol.
Yeah. Just one more comment to add. Let's think about it in this way. We all now, based on some security, like some encryption, some crypto, think about quantum computing that will allow us to break it just immediately. So I think that the next stage in AI, it could be something combined with quantum computing. It could be something, and it may also affect the way how we train it. So it doesn't need to be machine learning. But
and
maybe some other solution.
What about the machine learning? Will the automated scripts replace the testers or the developers?
Yeah, I already mentioned that also on my presentation that partially it could replace, but as I don't know if you know Tim O'Reilly, the founder of O'Reilly Media company. He also mentioned at one of the conferences, I guess it was 2 years ago, in London, that yeah. They will, I mean, AI, machine learning, the solution will replace some of the jobs that we currently have, and potentially the QAs are in this group where they can be replaced, at least partially. Some of the work can be replaced. There are some other jobs that will be totally replaced, like the taxi drivers, for example.
So actually, what you said that the tester or the human will be always one step further than the machine learning algorithm. Is that right?
The QA will be one step further.
Tester or the human that implements the machine learning code.
Yeah, but that's another topic, right? So that's something different. But just coming back to the jobs, don't be aware that you will lose your jobs. I mean, it's not something that you will lose. It's even if you lose, you will probably be someone like a QA who actually is testing the machine learning model, for example, or something that was on a higher level, or something totally different, like a job that doesn't exist yet, but will be in the future. Well, it's like, it's like with software developers. If you come back 100 years back, no one actually talked about software developers. Now it's one of the best jobs currently on the world, and it may change in the future. That it will not be like it is now, where we can actually choose in the office. It's like, with the coal miners, for example.
Yeah, it's just like the horses that were happy that were replaced by the farming machines.
And it will change, and then obviously AI will impact also our work as the software developers and data scientists as well. So it's not only related to QAs.
Okay, I see that Daniel have something to say also.
Yeah, I just wanted to add one quick comment about how machine learning could aid testers, and how not exactly it's going to eliminate jobs, but rather how I see it in today's society, that machine learning is actually going to be aiding testers side by side in their work. For example, the model, for example, that I created, it helped to analyze statistics that normally a tester wouldn't able to analyze all of them. So it actually makes tedious tasks a lot more easier and faster to do. And even when I speak with my friends and colleagues at work, I always hear, oh, this is so complicated, there's so much work to put in here, but if you only automate it, then it would make life a lot more easier. And so how I see machine learning is as a tool that would assist us in our everyday work to make it a lot better.
One comment to that.
Yeah, sure, go ahead. It's your time to shine.
It's similar, for example, with the doctors. When I did my PhD on skin cancer diagnosis, and I meet some of the doctors, some of them told me, that, well, yeah, but we don't like it. It can replace us instead, giving the diagnosis. But actually, it's not true. Even now, if you try to, you are able to develop a machine learning model to be better than the doctors by diagnosing, for example, for skin cancer. You are much better than the doctors do. But even that, because of the FDA approvals, because of some of the regulations and responsibility, we are not able to replace them totally. We can help them to increase the accuracy, the specificity, sensitivity of the doctors instead of replacing them totally. So it will partially, not really replace, it will more help actually them in the work rather than replace the jobs totally. But some of the jobs will be replaced anyway.
Okay, so you heard today in your presentation some big names, some fuzzy words about the machine learning, the quality assurance. And the next question is for you, Karol. And I obviously won't ask how you speak with your wife with using machine learning. That's not the case, like in your presentation. But how can be the machine learning used to improve the overall quality of the projects based on technologies or buzzwords such as IoT, the blockchain, or even the cloud services?
Well, there are two things. First of all, you need to be aware that combining more than one buzzword, combining two buzzwords together, it's a risk that, it's just a buzzword game instead of a project that will really help you do anything. But there are some proven projects, some proven solutions that show that actually it is possible to combine them. So, for example, blockchain. Now it's not so popular anymore because many people lost in Bitcoin. Many people don't see too many use cases of blockchain, except, obviously cryptocurrency, but apart from cryptocurrency, there are many other use cases.
It's always about the money.
But also that's cryptocurrency, obviously money. But the second thing is that blockchain can be used in different areas, and there are not so many use cases. But for example, we are at Coleta. What we do, we combined machine learning together with blockchain, but not in a buzzword way. Like if you put blockchain machine learning into Google and search, you may find some articles on distributed machine learning solutions, something like that. That's something ridiculous, something that if you think about it, why should I use it together? So what we did is we used machine learning not totally together with blockchain, but a separate system that actually is recognizing the pictures and finding it in the blockchain, finding the abuse of the pictures in the internet that someone used your picture, for example, and it's used then by the lawyers to go through the whole process next. And this is something that is working. It makes really money. Obviously, the cloud solution, there are many cloud solutions available. IoT, so you can use machine learning, obviously, with, for example, with the car sensors.
I see that Piotr is smiling, and I think he's willing to add something to your voice.
Yeah, so in terms of IoT, actually, and in terms of the blockchain, actually, I can't say anything anymore. Forgive me for that, because I have not much experience about this. But when we talk about the IoT, and I think this is similar to the cloud also, because we can use the machine learning to provide some performance testing or for detecting some anomalies or some performance issue, and machine learning can guide us to provide a better solution, to find better solution, and in this terms it will probably replace the manual QA work, but I think nobody wants to do that, so it's good to have a machine learning algorithm which will do this for you.
Yeah.
So you are saying that some of the manual QAs don't like to do it?
Yeah. Go ahead.
Just adding, just a general overview, I think machine learning can play a huge role in online security, cybersecurity. For example, around 2-3 years ago, the FBI had an official public warning stating that there were these stuffed teddy bears, and they had cameras built inside them, IoT of course, so that parents could monitor if their children are safe at home and stuff like that. Well, it later turned out that hackers were able to hack these teddy bears and be able to see everything that was happening at home. So IoT is, being able to secure these kind of devices, it's a huge thing. And so an example I also read about, Bitdefender, either Bitdefender or Kaspersky 2-3 years ago, they were working on a machine learning model or AI model that was able to detect these various anomalies happening in the network. So if by any chance you found like your refrigerator was speaking with your light bulb for some strange reason, then they were able to catch, okay, something's not right here. Maybe some kind of hacker trying to hack into your IoT devices. So it's very important that machine learning could analyze these kind of weird connections, because normally as a human being you wouldn't see that your light bulb is talking with your refrigerator. So that when it comes to the cybersecurity, another thing about blockchain. I think it could play a huge role in what are called smart contracts. For example, 2-3 years ago, my friends and I won this kind of small hackathon about how we could use the blockchain for the tendering process. For those of you who don't know what tendering exactly is for example, I have a company that wants to build a new building in Krakow, but obviously I can't build it myself, so I have to put out an offer saying that, hey, I want someone to build this for me, and then I get multiple offers, and the best offer wins, and then they get to build the building for me. So the problem with the tendering process here is that they usually are set up. You automatically know who wins, even though there are great companies that want to get the job, but obviously they don't, because the whole tendering process was set up. So we thought, hey, this would be an interesting idea to use blockchain for this, where we could make the whole tendering process private, and so that they don't know who exactly is giving them the offer, and the company that actually is the best actually wins. Now, combining with that, there are things called smart contracts, and these smart contracts kind of automate the whole entire process in blockchains. And so what I was thinking would be a great concept, which is kind of hard to implement really, but using machine learning to be an unbiased judge during this tendering process that would help determine whether or not the tendering process was just or not. So as part of blockchain, you could get really creative with machine learning. You could go even beyond IoT and stuff like that. So there are a lot of applications for machine learning, I would say.
Okay, go on, Karol.
Yeah. One more comment on blockchain and machine learning together. There are some examples of how you can combine it. One of it is how you describe. But let's imagine you have again. I come back to the example of doctors. So getting data of the patient, like images, it's something the GDPR. Problem that we have. We are not able to get the images because of some regulations, because we cannot actually, from a data science perspective, I don't care who it is, who this person is, what's the name of the person, but I care about the image. Blockchain can be used to anonymize some of the data, actually to put it in the blockchain, to anonymize it and use this data as a source for the blockchain, for machine learning. So that's also one other use case of how we can combine these two together. And I'm not sure if this is really used in many production-ready applications, but this is something that I can imagine can be used easily in medicine and healthcare. How to combine these two together? Not totally. I mean, not use machine learning model in the blockchain as a smart contract, but using as a separate solution, supporting each other.
I think we just started gossiping, and I like it because I assume that all are the enthusiasts of the machine learning and data science and artificial intelligence, with you also on our audience. So my next question is for Piotr. What, in your opinion, are the most interesting ideas or topics presented in the last NIPS conference?
Okay, so I actually analyzed some of them for my presentation, and I was talking about the adversarial examples, which are the examples that we can use to attack neural networks, and there's a lot of work done in this area. The same applies also to the reinforcement learning, about applying reinforcement learning to different problems, but also to enhancing it. And the other things, of course, we have a lot of new architectures of neural networks. This is the standard thing, but actually the huge progress was made with the moving from the recurrent neural networks, which require a lot of time to train, because it's not so easy to parallelize the types of networks, to the transformers models. And actually, the model that was used to the GPT model that I was talking about from OpenAI is the transformer one.
Okay, did you already start to use any of these methods, or just reading about it and learning?
Actually, this is part of my thesis.
Oh, okay.
So yeah, NIPS, I guess the next conference is this year on December. So just if you can, you should actually join it, or at least read the articles. I know there are around 1,000 articles every year, so it's quite a lot to go through, and not even possible to go through all of the articles by its one by one. But for sure, there is as every year. There are combinations of deep learning models combined with some, for example, shallow methods like the convolution neural networks, where actually they use kernels, known from SVM, for example, into as a different layer in convolution neural networks that give better results at the end. In some cases, we see obviously the trend of deep learning is still. It's still valid. I mean, there are more and more new architectures like the CapsNet, for example, that are introduced that are quite interesting. The thing about NIPS papers is that most of them are just in theory. I mean, you see that the new architectures, new solutions are introduced, but at the end it takes some time, 1, 2, 3 years, to actually use it in some examples, real world cases, to see if this really works. So yeah, NIPS, and there is also the computer vision CVPR conference, which is also very, very popular, but more focus on the pattern recognition, on the computer vision topics, which is also quite, on trending now. There are many examples like the one that you presented on the presentation today. So yeah.
Okay, so let's hear from the Daniel.
Yes, I agree. There are lots of very interesting articles. Unfortunately, too many of them to read. But the one that really caught my attention recently was this article about assisting feeding using a human-robot interaction. And so basically helping handicapped people who can't really move but are paralyzed from the neck down, a robot being able to properly feed them, and to be able to teach that robot, combining it with reinforcement learning a little bit, it's really a great thing to see, because on a day-to-day basis, probably many of you think AI, end of the world and stuff like that, but you really start to see good things being used with AI, and especially such as helping handicapped people and people who are disabled being able to function properly. And going a little bit beyond that, I recently read an article that the first paralyzed man was able to walk controlling his mind, and the whole exoskeleton was helping him to walk. So it's really a great thing to see that AI is moving in a good direction as well, to help people who really need help in this world. So yeah.
You talk about the RoboCop movie.
Okay, so let's summarize the other ideas you just presented and use 1 or 2 words for your top interesting methods, so the audience could remember the actual names of these methods. So let's start with the Karol.
Methods, new
or
architectures.
ideas.
Yeah, for example, GAN methods, they are evolving now. You can see that there are more and more methods, more solutions that use that, and more different methods that actually are GAN's methods, but they are modified in a different way to actually give better performance. So I would recommend actually this kind of group of methods to investigate a bit more. Obviously, convolution neural networks in different ways. That's if you see a machine learning solution somewhere around, most of them, especially in the image recognition, the video recognition, is based on convolution neural networks. So for sure, it's very important to follow also the changes in here.
My quick opinion, reinforcement learning, combining reinforcement, the whole concept of reinforcement learning, and combining with robotics to be able to really automate these things that are usually you need a human intelligence to help, but can really help people who really aren't able to move and are handicapped. So being able to combine these kind of technologies, such as reinforcement learning with robotics, to really do good things and to help others.
Actually, reinforcement learning, for just one example, they are quite popular now in the flight simulators to teach them to, at some point we will maybe fly without the pilots.
And Piotr?
Which sounds a bit dangerous.
And Piotr, what is your top one?
Okay, so I would say the adversarial examples and preventing the adversarial attack, because we have to have the robust machine learning methods if we want to introduce it in safety critical systems.
Okay, thanks. We see there is a lot to talk about the machine learning. We see that it's some buzzword and it's very trending topic, especially in social media. And my question is for all of you, and someone of you has to answer. Is the next winter of AI coming soon, and when it can happen? Yeah, it's your moment to shine. Go
okay. on. It will not come next year. There are some articles that you can find on social media that they talk about AI autumn, so not yet winter, but we are going in this direction. I think that the AI is quite a wide topic, so we can talk about speech recognition, we can talk about convolution narrator use for finding objects on the images on the movie in the movies and videos, and many other topics that are related to AI, and some of them are already in the phase where I would say way they are stable. There are not so many. I mean, they are not so interesting like it was a couple of years ago. So we still have a couple of years before we will reach this point. Another thing is that a limitation is that many the big companies, they have data, they have a lot of data, they have many data science, they really can do many new many new applications of AI. The problem is that the smaller companies, and this is a limitation that may actually move us a bit closer to the AI winter, is that the smaller companies, they are not able to generate enough data, especially in now we use quite often deep learning, and it's not true that you need to have a lot of data for deep learning, but in many cases it's it's better to have more data than not, and it can be a problem for the smaller companies to actually reach this point, and we will come to a moment where actually the big brands, the big companies will still move the whole AI part, the application. They will introduce more applications, but the smaller ones will be in a difficult position. So this can at some point move us to this this position. But we need to also think about quantum computing and also what will be before that, right? That this is something that I think will be also a big difference for machine learning. And I hope and think that between that there will be AI winter. I already, during my research, there was already one in the past. So we're still alive, still do data science, still do machine learning. So, well.
Yes, I definitely agree about the lack of data. That is something that I even myself had a problem with working with my project. However, when it comes to seeing a potential AI winter in the near future, I would have to slightly disagree. For example, companies such as Nokia itself had just recently, last year, came out with the initiative that, hey, we should probably start going in the direction of machine learning. So it's not really dying down, but we're just only starting to find various ways where we could actually use machine learning on a day-to-day basis, because we haven't really tried all the areas, because many people will say, yeah, we don't have enough data, there's no point of even trying. But in reality, if we don't try, we won't know if it actually works or not. Yes, I know there's that problem that companies are forcing a machine learning, and yes, that is something that's to think about, but even so, it's worth trying to see whether or not if it's possible. Because if you try and you see that there is some kind of success, that there is a possibility that machine learning could really help a lot, then we could continue to work on and evolve in our companies. And so it doesn't have to be something advanced, even like using deep learning or all these kind of methods. We could stay simple to like the basic methods of a linear regression or whatever, depending on what we exactly need in our task, in our job, to simplify the task or whatever it may be. So to see an AI winter, it might take a while still before we actually see one, because I think a lot of companies are still going to be trying to figure out and work things out, try and fail at the same time, whether or not machine learning fits for them or not.
Just to be precise, I would like to be more precise on that. It's very hard to predict in what will happen in 10 years, but I think in a couple of years we still will not face AI winter. But in 10 years, I don't know.
Maybe. Okay, go, Piotr.
Okay, so I agree with guys definitely that it will take time before we will have another AI winter, and I agree with Daniel about that even if the big companies or researchers will reach some limit, we will still have a lot of places and areas when we can apply existing methods. So that is definitely something that will be done even if there would be some AI or Atom or something like this. Yeah, so I think that's...
Okay, let's do some exercise and answer on question from the audience. One is from the Piotrek. What are your favorite use case of machine learning models, and are you that especially in testing area?
Machine learning models in testing.
Yeah.
So my favorite one, well, I mentioned about our solution that we have published on open source. So this is something that where we used machine learning pattern recognition for finding bugs. That's something that I think is one of the use cases where actually you can use machine learning, not because of buzzword, but because of benefit that you get from what the machine learning model find. I mean, bugs that the model find. Yeah, this is one of the use cases that I think it's most of it actually are not so sophisticated models. Usually are still shallow methods used for QA at least.
When it comes to models, obviously, for many of you who ever entered a Kaggle competition would agree with me, but my favorite, I think for now is going to be my favorite, XGBoost model. It's very good. It technically can combat various problems such as with bias and variance and underfitting and overfitting supposedly, because it uses techniques such as boosting and bagging. So boosting meaning that you learn recurrently from your previous errors, so you don't make the same errors in next iterations. And bagging is when you create smaller models. Yes, you create smaller, weaker models and then combine them in an ensemble voting system to create a much more stronger method. So they use these kind of techniques to really solve most problems. Obviously, it doesn't solve all problems, unfortunately, but it's probably one of my favorites for now.
And it's a shallow method.
And for me, of course, I'm a very big fan of neural networks, so definitely this is my first thing of choice. But if you're talking about the shallow methods, I don't know if this is because sometimes of lack of data, but with the techniques like transfer learning, we can apply the bigger and more capable models to do the simple things even with the limited data. So I will stick to neural networks.
Yeah. And what about the using of deep neural networks in case of testing, like system logs or some KPIs like Daniel showed us in his presentation? What do you think? Maybe you, Daniel, start.
That's actually very interesting. I was at a different conference once in the beginning of January, and I actually spoke with someone who actually, I think it was neural networks or some type of networks, how you could backward test. So basically you have the results that you want and then create like the scenario or basically a backwards testing. You have the results that you want and then backwards testing to what kind of scenario basically generates these kind of results. And so by using deep learning, We know what we want to achieve, and so since we know what we want to achieve, in the tests that we make in the future, we know what we should be making and what kind of mistakes we should be avoiding in testing especially. So that would be a great use of deep learning. Of course, if we had the right equipment and the right amount of data to do that, but it would be a great thing to see.
Yeah, thank you.
Maybe an unusual use case, generating data for test cases. Could be also done using...
So the machine learning feeding the machine learning.
Could be, but not only machine learning, but also just to test cases, just the data for test cases using some GAN methods, autoencoders, for example. That's something that you can also use, and this is a deep neural network. Both of them are deep neural networks, usually. And yeah, so that's another use case that I think could be valuable for the keyways when we talk about deep neural networks.
Can you use these methods to let's say, to start some chain of analysis, like that output from the first neural network autoencoder can feed the input to the next part of the model, like I say CNN, to narrow the problem down and.
Technically, you can do it. But the only thing, the question is of the use case, if it really makes sense for you. So it's about, because for example, the GAN methods they use already some fake data and some real world data already. So they just generate some data that looks like a real data. At least this is how they are developed, how the architecture is working. So yes, you can use it for the machine learning model, but I think it depends on the case. So for me, the simplest way how we can use it is more like using data for, just to avoid the pesticide effect in the test cases, in the quality assurance, to generate new data sets. But it's a difficult topic, and you really need to have a lot of scenarios to actually to make it possible to use it. That's one thing, and obviously you need to have a lot of data to really train the model. That's another thing. When it comes to the log files, it depends on the log files, because some of them actually it would be easier to use some NLP methods to figure it out rather than just using NLP and behind it there is some machine learning usually. But maybe just such an NLP or maybe just regular expression, which is not a machine learning solution obviously, and well, it depends, right? So there is no one right answer here.
So let's stick to the testing. And I see there is a question asked by Alex. No, it's from Alex, the second question. I see the first one, to be honest. Do you have any concrete example of machine learning used for regression testing? Maybe let's start with Piotr. Did you use any of these methods?
Actually, I haven't chance, so
I see.
I can easily move. If you go to YouTube and put my name, right, my name in YouTube, and also put TestDive, right. So you will see a movie from the last year from the conference, and I explain exactly how we can use machine learning for regression tests. And today I even gave you a link how to get this solution and use it by your own, because it's open source. So yes, we use it, and it's really valuable, especially when you have many pages, for example, to test something that is you need to spend a huge amount of time to really cover the application with test cases. That's a big value, and even 4 of our customers use it already. At least 4. I guess there are even more than 4 customers that use it, and maybe some also that we don't even know, that are not even our customers that use it, because it's open source. So feel free to contribute to it, and you can find more information on YouTube from TestDive from previous year and also from this year.
Yeah, I will start. Thank you.
Whoever asked that question, I hope you were at my presentation this morning, because I exactly talked about using it for regression testing, especially for performance regression testing, where basically we analyze statistics that are generated at the base station at ENOBs, and then we determine whether or not any possible errors are occurring. And we do this by basically teaching our model on historical data. So we had a huge database of previously tested regression tests, and which were labeled passed and failed. And so based on that, we had labeled data, and we were able to teach our model, which was able to then make predictions on future tests. And then additionally, using features such as SHAP, which were able to explain why a certain maybe statistic caused a certain test to fail. So we even went one step further and trying to find the root cause. And going even one step further, right now what we're trying to work on, trying to analyze logs in general, logs that are being generated from these tests to see whether or not if they're correct, what we can interpret from them, what kind of insights we kind of get from them. So we're starting to work on stuff like that, and we're going to see what we can get.
Okay, we're almost out of time, so let's focus briefly on the last question. That one is from the E. What skills are the most needed and useful to start with working with AI or with the machine learning?
Can you repeat that?
What skills are most needed and useful to start working with the AI or machine learning?
What skills?
Let's do it briefly because we're almost out of time.
Skills. Honestly, to really get started with machine learning, you don't need too many schools to really get started. Obviously, to get more focused on what is happening, it's good to have some mathematical backgrounds to know what exactly is happening in the background. But to get started, you don't really need too much. Like, for example, using scikit-learn with Python, those are very basic models that you can start using, testing, and training your model to see various things. So you don't really need too much to actually get started.
If you would ask this question 10 years ago, probably you would get an answer like you need to have a PhD to do that. Actually it's not so hard. I mean, it's not that something changed how to learn machine learning, but it's well, it's not so hard. Obviously, some mathematical background is good to know what's going on in the background. But you know, some Python knowledge or any kind of language that actually has a framework for machine learning. Even JavaScript is fine, right? You can use TensorFlow.js to build your first model, and that's fine. So now we have so many tools that it's easier than ever, really to train to learn machine learning. So it's not so easy to like learn JavaScript, where actually you need just a browser, but you need to learn a bit more, like TensorFlow, Keras, how to put them together, how the layers work. But it's much easier than it was a couple of years ago.
So, a few last words. And
exactly. Just Python.
Yeah. Okay. I think we are out of time, and thank you for attention and helping us with this discussion. And we see you next year. Bye bye.